Can you hear me? Is everyone able to get me? Good morning. Okay, so we revise the second, this that you just wrote, entry, that is test 2. Are you able to get me clearly? Hello? So question 1A, 1. Want to show that the function is even or odd or neither. The given function is f of x equals 3x squared minus 4x. So we can check f of x equals f of x. Now that this is the condition for checking whether the function is even. So let's make the input negative. That is where x is. We substitute, we put or we write negative x. So we have f of negative x equal to 3 negative x squared is 4 negative x. When you simplify, we get negative 3x. Hello? Okay. So note that the power is not power 2, but power 3 instead. So we have x power 3 here. And so this is x power 3, x power 3 plus 4x. When you factor out the negative, you get 3x power 3 minus 4x, which is the original function f of x. So what we've just shown is that f of negative x is equal to negative f of x, which shows that f is an odd function, which shows that f is an odd function. Okay. Then the next part, the next part, I believe everyone is able to hear me, right? Hello? Okay, so we proceed to the other part. To sketch a given function, we'd love to sketch f of x equals 3, x to the power 3 minus 4x. So sketching this function, polynomial, we need to get the x-intercepts and the y-intercept. So for the x-intercepts, we have x, we have y equals 0. And so we have 3x to the power 3 minus 4x equals 0. We can factor out x here, since x is common on both terms, so we can put it out of the brackets. And so we have 3x squared minus 4. Minus 4 equals 0. So we get x equals 0. Since the product of the two factors, this and this is 0, it implies either this factor is 0 or the other one is 0, or both are zeros. So, or 3x squared minus 4 equals 0. So 3x squared 4 equals 0. As we can see from the previous page. Okay. We can factor out 3x, 3 I mean, so that we have x squared minus 4 over 3, because, yes, Jonathan. Hello?
Can you put back the first page? Just
The previous screen. Okay, this one.
yes.
Yeah, what is your concern on this one?
No, I just wanted to copy. Thank you.
Okay. You're done?
Yes, sir.
So we can divide on both sides by,
Sorry, sir.
okay, yes, please.
Just put back the next page. Just need to copy something quickly. Okay.
So we can divide on both sides by 3, and so we get x squared minus 4/3 equals 0. We can factorize this using the difference of square method. So we can write 4/3 as the root of 4/3, then we square equals 0. We know that root of 4 is 2, so we have 2, then over root 3, or the square, which is the bracket. So by difference of two squares, this can be written as x minus 2 over root 3 by x plus 2 over root 3 equals 0. Now, the product of these two linear factors is 0. The product of this and this is 0. It implies that either this is 0 or this is 0 or both are zeros. Because you can't multiply 9 0 terms and get a 0. One of them must be 0, both to be 0. So we have either x minus 2 over 3 equals 0, or x plus 2 over root 3 equals 0. So that x is equal to positive 2 over root 3 or x equals negative 2 over root 3. And then we had gotten one value of x already. We had gotten x equals 0. Now plus these two that we have found.
Your voice is too low.
Pardon? Or my voice
Your
is too
voice
low?
is too low.
Okay,
Yes,
let me increase it a bit. So we had obtained two values of x. I mean a value of x, which is x equals 0 plus these two that we have just found. So we have the three values of x. So these are the x intercepts. Any question on this? Can we proceed? Okay, let us now find the y-intercept. Y-intercept. We know that for the y-intercept, x is 0. So when you substitute 0 where x is in the given function, we obtain y equals 0. So we have gotten all the intercepts. It remains now to sketch the function. So we can sketch the function. So this is an intercept, which is x equals 0. This one. Then we can plot the other intercepts as well. For the positive one, we have 2 over root 3, and then the negative one, negative 2 over root 3. So between this intercept and the other intercept, you can get some value of x in between here, get a value of x in between. That value, substitute it into the given function to obtain the value of y. So if you obtain y to be negative, then your turning point will be below the horizontal axis. If you obtain a positive value, then your turning point will be up. So in this case, your turning point will be somewhere there. Between this and the other point as well, this point and that point, get the value of x in between, substitute it into the given function, and obtain the value of y. You're going to obtain a negative value, so your turning point will be below. Then we can now make a sketch, and so your sketch will be to pass through this point like that. So this is how your sketch will be. And from that end, the domain of this function is known. The lower bound is -2 and the upper bound is 2. So when x is 2, here, what is y? You obtain y to be 16. Where x is, when you replace 2, you substitute 2, y will be 16. Similarly, on the other part, the lower bound is -2. So when x is -2, what will be the value of y? You substitute in the function, you obtain y to be -16. So this is your sketch. Any question on the sketch? Okay, we proceed to the next question. We solve the given equation. One over x minus 1 minus 1 over x plus 1 equals 5 over 4x plus 8. So on the left, we can simplify the two fractions. Since you are experts at solving fractions, you know that you have to get the common denominator and the like. So you get this. X minus 1, x plus 1 as the denominator. Then here you have x plus 1 minus x minus 1 equals 5 over 4x plus 8. So simplifying the numerator here, you get, and expanding the denominator as well, you get 2 over x squared minus 1 equals 5 over 4x plus 8. Then next, you can do some cross multiplication. So you have the 2 multiplying 4x plus 8 and the 5 multiplying x squared minus 1. Expanding gives you 8x plus 16 equals 5x squared minus 5. Collecting the like terms and then simplify gives you 5x squared minus 8x minus 21 equals 0. So we are obtaining a quadratic function, a quadratic equation, and we've written this in the standard form. Next, we have to solve this quadratic function. Solving this, we can use completing the square method, and we understand quite well that for us to complete the square, the coefficient of x squared has to be 1. The coefficient has to be 1. So in this case, it is not 1. So make it 1. So we divide it throughout by this coefficient. So we get x squared 5 over 5 minus 8x over 5 minus 21 over 5 equals 0 over 5, which simplifies into x squared minus 8 over 5 x minus 21 over 5 equals 0. Then we get the coefficient of x. The coefficient of x here is negative 8 over 5. We are going to divide this by 2. So the coefficient is negative 8 over 5. We divide this by 2, which implies multiplying by half. And so we get negative 4 over 5. So this is now half of the coefficient of x. So this value, we're going to square it, then add and subtract. The reason why we have to add and subtract the same quantity, we don't want to change the equation. So we have x squared minus 8 over 5x. So this also implies we're adding a 0. You know that adding a 0 doesn't change anything. It still remains the same equation. So now this 0 is the one that will be written in terms of half the coefficient of the square, half the square of the coefficient of x. So we have minus 8 x over 5 plus negative 4 over 5. We square this and subtract the same quantity. 4 over 5 squared, then minus 21 over 5 equals 0. So the three terms can be, first three terms can be written as x minus 4 over 5, then we square. So you observe that when you expand this, you're going to get these three terms. So now it remains to simplify this part. So we have minus, when you square here, we have 16 over 25. Minus 21 over 5 equals 0. Since we are experts at the adding and subtracting fractions, so you simplify the two numbers. And so the equation becomes minus 121 over 25 equals 0. Introducing the additive inverse of this on both sides, since this number has got no legs, so it can't cross the equal sign. But you just have to introduce the additive inverse. This gives you x minus 4 over 5 squared equals 121 over 25. Taking square roots on both sides gives you x minus 4 over 5 whole square root of 121 over 5, then say plus or minus. So we have x minus 4 over 5 equals plus or minus, okay, this is 25. So when you simplify the square root, you get 11 over 5. Okay, so in the next few minutes, the meeting will cut, but then we'll restart and continue. I think looking at time, I have another class. I'll just send you the video that I've recorded, then we'll pick it up from where we're going to end. Yes, Kazu? Skazwe? What's your concern? Ntemesha? Should we move on?
Yes, you can move on, sir.
Okay. So we have x equals 4 over 5 plus or minus 11 over 5. When simplified, gives 15 over 5, or x equals negative 7 over 5. So we have 3, x equals 3, or x equals negative 7 over 5. Now, there is a condition which we are given in the question that x must be less than 0.
Sir, kindly tell Father to mute himself or herself.
Pardon? I didn't hear you.
I was saying, kindly tell Sikado to mute himself because he's making noise.
Okay, Skazo, can you kindly mute? Okay. So because of this condition that x must be less than 0, and so the required value of x would be this one, because x equals 3 is above 0. So we have x equals -7/4. That's the required value. Then you've solved. Any question on this? Yes, you can ask, please.
Step 3.
Pardon?
Yeah, step 3 where you find the x. Step 3, x where there's 2 divided by x minus 2. How did you come up with 2x minus 2 from x plus 2, x plus 1, I mean minus, okay, bracket x minus 1 divided by x minus 1 bracket x plus 1.
In the previous screen?
Yeah, the third step.
Okay.
Where is x divided by x.
Which part is that? Is this part or the left part?
Pardon?
Is it this part?
My question is on 2 divided by x square minus 1.
Okay, how we got this?
Yeah, exactly.
Okay. So you have x plus 1 minus. So this negative will be distributed throughout those of brackets here. So when you distribute this negative, this x becomes negative. Then negative by negative, we have a positive. So you have a positive 1, and here also you have a positive 1, isn't it? Which will add to give us a 2. But then this x will be negative plus the positive x. The 2 will subtract to give us a 0. So we have 2 plus 0, which is 2. This is how we're getting this 2. And then for the denominator, we just expanded. X times x giving us x squared. X times 1 giving us x. Giving us x. We're getting x. Then negative 1 times x giving us minus x. Then negative 1 by positive 1 giving us plus 1. So you observe that this x and x are adding to 0. Okay, so that's how we got this denominator. It's just some normal expansion. You just expand it. I don't know whether you are clear. Are you safe?
Yes, I'm clear now.
Okay, okay.
Exactly.
Excuse me, sir.
Excuse?
I want to ask, the word from expands the 1 over x minus 1 minus 1 over x plus 1. Is it wrong if you bring the 5 over 4x plus 8 on the other side instead of cross multiplying? Can you like just do minus and solve the fractions like that?
Okay, that is also correct.
So you can also solve it like that by bringing the 5 over thing on the other side, like minus 5 over 4x plus 8.
Yes.
Okay, sir, thank you.
You're welcome. So this meeting was timed and it is ending in the next minute. It's less than a minute now. So let me just send you the video that I've recorded going up to question 2. Then if you have some challenges, you can still inbox, then I'll be able to help you.